speaker is a technical evangelist from AWS. Please welcome Danilo Poccia. Thank you, sir.
Thank you. Hi, everybody. So for the last presentation of the day, I was thinking to take a different perspective in the use of Git. So to see how you can use Git not to manage only the source code of your application or maybe your documents, but also how to manage your architecture, your infrastructure with Git. And why you would do that? Why you would use a tool like Git to manage your own infrastructure? Well, in the past, we were used to design very simple architecture. So there was a presentation tier, some business logic, and then a persistence tier. So probably this architecture is not that difficult to manage. But what happened is that the internet is scaling and growing so much that the modern architecture, they really don't fit into a multi-tier diagram. So this slide from Adrian Cockcroft, the former cloud architect of Netflix, shows us the number of modules and the interaction between the modules that compose a large-scale system is really different from what we used to perceive. And so we cannot use the normal tools to manage this kind of architecture. We have dependencies. We have a lot of modules. Doesn't it not resemble the source code of an application? So there is something similar that we can reuse. And actually, I literally jumped on my seat when I was reading this article on reactive programming, because this is true. So I think a single web server now, and probably the people that talk today, like Twitter, they experience that every day. They have more traffic today that, on a single website that the whole internet was having 10 years ago. So we are really working on a different scale. So managing the infrastructure as code can really help. It can help because we are talking about writing code to manage your configurations and to automate the provisioning of your infrastructure. The important thing, though, is writing code, not doing that through a web interface. Because when you write code, then you can reuse all the tools and the best practice of software development and of software architectures. So when you have your infrastructure described in some text files, like you can do with tools like Puppet, Chef, of CF Engine, then you can put the source code of your infrastructure under version control, so that if someone is changing something, you do the commit on the code, send the delta to your infrastructure platform to deploy the changes as required. And then you can roll back to a specific version of your infrastructure. In the same way, you can roll back to a specific version of your software application, because you know that that version was still working, and it's helpful to go back in time sometime. And also, you can use this for testing, because if you have all your architecture described in a text file, you can use a disposable architecture, like a cloud architecture, where you can create resources, use them, and destroy them when you don't need them anymore. And so you can create a test environment on demand, because you have all the information that you need to create this test environment, use it, and dispose of it after the test has run. And also, you can use other best practice from software development, like small deployments. It's much easier to bring in production a lot of small deployments that are big changes that probably break some behavior. And the same can apply to your infrastructure. So if you need to change your infrastructure, do this in step, and bring every single step in production so that you can test every single step is affecting some other part of your overall system. And so in general, you can apply all the design partner of software development to the management of your infrastructure. And here I'm particularly thinking about continuous integration and continuous deployment. So the fact that you can continuously adapt and adjust your infrastructure depending on the changes that you do on your infrastructure code. And you can also have multiple stages that will become multiple environments for your infrastructure, so that you can run your application through multiple stages in a pipeline that will bring your application hopefully in production. So this is something that we usually have with a continuous integration system. So you have your application code, your Git repository, and when you commit your changes, you in some way talk with a continuous integration system that will deploy your application on an infrastructure that is already there. But if you have also your infrastructure code, so the code describing your infrastructure in the same repository, you can version them together so that version 1 of your application is using this infrastructure, version 2 is using this other infrastructure, and the continuous integration system can build the overall environment in a cloud infrastructure and deploy the application inside this to test it or to use it in production. And we will see that with AWS, there are two services that allow you to do that very easily. One is Elastic Beanstalk that is very easy to use, especially for developers. And one is CloudFormation that is more powerful because it can help you to describe the overall architecture in a group of text files. So let's start with Elastic Beanstalk. So Elastic Beanstalk is very easy to use and allows you to deploy a web application or a web service. And you just need to give to Elastic Beanstalk your code, can be Java, .NET, Node, PHP, Python, Ruby, Go, or can be one or more Docker containers. And this package of the application is given to Beanstalk that will create a whole environment, an auto-scalable environment, or a single host environment for a test purpose. It is dedicated to you. It will do log collection. It will version your application and store the log and the version of your application on a durable storage like S3. So that you can really don't care about how to implement the infrastructure. But Beanstalk is a little bit more powerful than that. When you create an application with Beanstalk, you can have multiple application versions and multiple environments. Like think of test environment, production environment. And you can tell Beanstalk to deploy a specific version of your application into a specific environment. And everything is done automatically. So Elastic Beanstalk can integrate with Git so that you can map a Git branch to a specific environment. So the test branch goes to the test environment, the master branch goes to the production environment, for example. And you can also map a Git commit to a specific application version so that when you commit something that you want to deploy, you can automatically create a software version for Elastic Beanstalk. So we have a situation like this where you have your application infrastructure code in Git. You can have multiple environments. I did just a couple here in this example, like test environment and production environment. And then you can link the develop branch to the test environment and the master branch to the production environment. And then you can use git commit to commit your code. And EB deploy to deploy this committed version to the specific environment that is bound to the branch you're using in this moment. EB is the command line interface for Elastic Beanstalk. It's a Python package that you can install on any system with pip install. So it's very easy to install. So let's try the first demo of my presentation. So for this demo, I created a Hello World application with two environments. So these two environments are called -prod and -test. So here I have a single file, and this is not versioned right now. So I can run git to create and initialize the Git repository. And this file is a very basic, web server. So it's just answering hello world to any kind of question that you get. So now what I can do is I can commit this version. So I can add this file and commit as the first release. And now I can initialize with EB, and you see that the syntax is very similar to the Git syntax, this environment. This will connect to my account. We'll see the available application. We'll see there is already one application. I can create a new one. I use the application that is already there. And now it's asking me if I want to bind this branch. Now, of course, after the first commit, I'm in the master branch to one environment, and I want to link it to the production environment. Now, if I do git branch, I can see that there is the master. If I do AB list, I see that there are two environments, and the asterisk is telling me which environment I'm using now. So I can run AB deploy, and this will deploy this version so that it will be packaged and sent to Elastic Beanstalk. And as you can see now, the command is done. I can interrupt this window. It's not important anymore because everything is already running here in the cloud environment. The environment is updating. Here I have all the events. And if the gods of the demo are not looking at me right now, the environment will become green, and I can see the hello world here. It's slightly outside of the window. Maybe I can. And now you also know why I'm not a front-end developer, because this is the maximum. So what I can do now, I can use Git to create a new branch. So I check out a new branch that we can call test, in this case. And if I do a blist, now I see that I'm not bound to any environment anymore. So I can edit this file and do all the changes that I need to do to run into a test environment. So I'm running in testing. I can add the new file and commit the new version, ready for testing. Now I can tell EB to use one of the environments. So I can do EB use and give the other environment, the test environment, and this will tell EB to use this environment for this branch. This is a good time to stop testing the large file on GitHub and leave some bandwidth for the demo. OK, so we see that we are bound here. So if I run a deploy, of course, this time the deployment will go on the other environment. OK, and it's adjusting. I can also interrupt here because it's already done. And if I want, I can also create a new branch, like Git branch. Maybe I want to use it also for development. And sorry, Git checkout. Sorry. And I can also create a new environment from here with AB create. And of course, I will be asked all the usual questions to create environment, the URL to use. The DNS name, this is probably taken. I can call it hello world Git Merge, and so on. So now the event is creating, and then I can deploy in the new environment. This is the last deployment, and of course, the output is different. So the magic happened. So going back to the deck, this is the first way to use the infrastructure as code. It's very easy, especially for a developer. And if you want more information, there is this presentation by Coca-Cola that tells you how they are using Elastic Beanstalk for the deployment of their web infrastructure. But they also use CloudFormation, that is another tool that allows you to manage a collection of resources in a single text file or in a collection of text files. So in this case, you have this group of text files that we call templates. And if you give these templates to CloudFormation, it will deploy your infrastructure. If you edit this file and tell them to CloudFormation to update the stack, it will update the infrastructure accordingly. So the syntax of these text files is JSON, and there are four main four main parts. The parameters that allows you to reuse the same template in different occurrences, like you can change the password of your database, or the number or the size of the virtual machine that you want to use. The mappings that allows you to use this template in different regions. We have regions all over the world, and you may have different codes inside these regions. The resource, this is the declarative syntax of CloudFormation that will ask for the resource to be deployed. And the output that can be the HTTP URL of your website after it has been created by CloudFormation. So this is an example of how to ask for a relational database. I want MySQL engine, I want version 5.6, and I want this username and password. Of course, as I say, these are good candidates for being parameters and not being inside the file of the template. And this is how to customize a virtual machine that you just created. You use the package manager of the instance to install packages. This is an example to create a LAMP stack, and then download this source bundle from S3 and explode it under the path where Apache will look for the source code of your application. So it's fully creating and deploying a LAMP stack on a single server. So as we saw, the template and the parameters will create an implementation that we call a stack. And the template can be reusable for more than one stack. And you can map a different stack, for example, to a different environment, like we did before, so a test or a production environment. And the parameters are usually specific for a single stack because they will contain maybe the password of your database, or they will contain the size and or the environment that you want to create. So the parameters are good candidates to be stored into a configuration management. And let's keep this in mind because it will be my last slide that will link to this. We also have a tool, CloudFormer, that allows you to look at the resource that you already have and automatically create the JSON file for you with the resource that you select, so you don't need to create the file from scratch. So with CloudFormation, what you have is you have your application core, your infrastructure code, and then you can use CloudFormation to create and update multiple stacks, one for each environment, like a test stack or a production stack. In this case, for the very short demo, we will use this simple website. You have an Elastic Load Balancer, so a load balancer that is balancing a group of EC2 instances. So we're talking about virtual machine with a very basic web server. You can imagine from the previous example that my skills are not improved, so don't expect too much. And for the sake of simplicity, we will have a single web server into this group, and we will use text editing to add a second server. So let's quickly look at this. So if I go into so let's close this. This is the CloudFormation console. By the way, you see this other stack here. These are automatically created by Elastic Beanstalk because Elastic Beanstalk is using under the hood CloudFormation and on your behalf. But this other stack here, called infrastructure, is a stack that is creating the resources that I was saying, so the Elastic Load Balancer. We can see here the Elastic Load Balancer, the security group, that is the firewall protecting each of these instances, the configuration for launching a new server, and the web server group that can scale depending on your needs. If we go back to the text file, we can defer this. So this is my infrastructure description file. So these are the parameters, the size of the instance, the way to log in. I go fast here. At the end, we have the web server group. And this section here will tell the minimum size, the maximum size of this auto-scaling group, and the decided capacity. Since I didn't put any automatic scaling policy, this auto-scaling group is static, so we will stay with one instance. So let's say that I want more than one. I should edit this. So let's do git init. So we need git add of this file. Then we can commit the first release. Then we can edit this file and tell that we want not one, but two servers. So someone in the team is editing this file. And then we can add the changes and commit them. Two servers is better. Now I can use the command line to send an update stack based on the changes that I did. So I can say the stack name is infrastructure, and the file is template body should be. Sorry, this is missing one important part. That is an update stack. That's why. Now CloudFormation is receiving the new updated file, is looking at the difference, and it will run the update. So if we look here, the update is in progress. And here we get all the events that are happening on the stack. And this will change the configuration of the auto-scaling group, and in a few minutes, the instance will be changed from 1 to 2. So I'm moving the EC2 console just as a reminder, so that we can have a look at it after. So you see the second instance is already starting, and this is this demo, and it will get a name at the end. So I think I try to give you an idea of how you can use text files to describe your infrastructure and use Git as the way to version and manage your infrastructure so that it's very easy, for example, to link the stack update or the AB deploy commands to your continuous integration server so that when you commit some changes, these are automatically propagated not only for the deployment of the application, but also to the infrastructure. And CloudFormation is used by a lot of our customers like Adobe, Expedia, Sega, and also it's used by this little robot on Mars, the Curiosity rover, that so the NASA is using CloudFormation for deploying resources that allows to get the information back from Mars for this robot. And if you want, you can have more information from this talk. There is the BBC, so the British broadcaster, that tells us they are using CloudFormation for management and deployment at scale. So in the past, we used to think about application and infrastructure as two different words, two different teams, the developers and the system administrator, that they should not talk together. I think that now the real distinction is between data and code, and there is data in the application and in the infrastructure and code in both. So this is the first step for a company to understand and to embrace the DevOps culture, in my perspective. And what I think is still missing in the use of Git, and this is a question that I'm making to you, is how to manage configuration management. So you have configuration management for the application and the infrastructure, because you want to customize passwords, you want to customize the size of your infrastructure depending on the environment. So what can you do? So the best idea that I had is to use Git submodule. So you use a different repository for configuration management. This also is good for security, so you can give permission to access this configuration management repository only to who can really do that. And then use Git submodule add to add this repository to the environment that you want to customize for a specific configuration. So if you have any better idea, I really would like to hear from you, because I think it can be provide a better experience for using Git to manage your architecture. Thank you.